In this question, we are given a toy rocket which is launched from a platform whose path and the path of the rocket can be modeled by this equation here. Okay, h is the height in meters and t is the time in seconds. So even before I try answering the question, what I always like to do with word problems that can be visualized is actually draw a picture. So I have a toy rocket on a platform. Here's my platform. I'm going to make my rocket here. Comes up like this. And I know that this rocket goes up in the air and comes down. So it's a very simple scenario. And this way you can see where the parabola is. The height of the rocket is given by h, and that's on the vertical axis. And the time is on the horizontal axis is given by t. And again, I'm assuming time goes forward in this case. The first question is the height of the platform. What is that height? Well, in order to figure that out, what we have to do is think about the scenario here. When the rocket is launched, the time is 0. And at that time, the base of the rocket is sitting on the platform. So if I can substitute in 0 into my equation, I can actually get the height of the rocket. So let's take our equation and replace t with 0. So the equation here is h equals negative 5t squared minus 50t, plus 50t, and then plus 2. So when t equals 0, I'm just going to copy this, we get the height of the platform. So let me just replace all these t's with zeros. So I get a 0 here, I get a 0 here. All these products and their sum are going to be 0, except for the very last one. If I add 2, I end up with 2. And that is your platform height. Now you could have read that off the equation itself. It's just the last term, the constant in the standard form. And from here on in, you can always do that. Okay, just you see it once, you realize that there's going to be some kind of pattern going on here. Okay, if I plug in 0 for t, all I'm left with is the constant at the end. So the height of the platform is 2 meters, and that's here. Now the second part, here's where the work is involved. What is the maximum height reached by the rocket? In other words, where is the vertex located? Okay, and what we're going to do to find that vertex is the process known as completing the square. So I'm going to take my equation again, and I'm going to complete the square with this equation. So step number 1 is to divide out the negative 5 from the first two terms, because this is a quadratic where the leading coefficient is different than 1 but not 0. And I'm left with 10t and then plus 2. Off to the side now, I take that negative 10, I divide it by 2, which gives me negative 5, which I then square. And the result of that square, which is 25, I add and subtract inside the brackets. So what I'm left with here is negative 5, open bracket, t squared minus 10t. Then I have a plus 25, and I have a minus 25, close bracket, plus 2. And I'm almost done. Now the first three terms inside the bracket, these guys here, end up being a perfect square trinomial. So if I can just write that as t minus 5 squared. And this last term, the negative 25, before I take it outside the brackets, I have to multiply it by the negative 5 in front. So 5 and negative 25 gives me positive 125. Then I have a plus 2 at the end there. And what I'm left with is negative 5 t minus 5 squared plus 127. So there it is. There is your vertex form, and from that I can read my vertex, which is going to be 5, 127. This point here, let's just relate it to our picture, refers to the vertex, which is right here at the top. A bit too big. There it is. Keep in mind the x and y axis of this scenario. Here's my y axis, because this is where it's starting. And my x axis is along the ground here. there's my x-axis. My vertex is 127 for the maximum height. So when does it reach this maximum height? Well, that's just the x-coordinate of the vertex, which in this case is 5 over here. So that's 5 seconds. So the maximum height, by the way, is 127 meters. And last question, the height of the rocket after 4 seconds. Well, 4 seconds is just a little bit before 5 over here. All I have to do is take that value, substitute it into the equation, and what it'll give me is the height of the rocket at 4 seconds. So here's what I'm going to do. I'm going to take my equation and replace the t with 4. So over here I have equal negative. I'm going to take out this t, replace it with a 4 here and here to give me negative 5 times 16 plus 200 plus 2. 5 and 16 gives me negative 80 plus 202. And my final answer is 122 meters. So that seems to make common sense because it's lower than 127, but it is close to 127 because 4 seconds is very close to 5. Another question for you to answer is, when else will the rocket reach the height of 122 meters? So I'll leave that for you to figure out. The answer is very simple if you just keep in mind the symmetry of the parabola.